Welcome to HYTORC's Hand Safety webinar. We'll go ahead and get started. It's 1 o'clock, 1 o'clock Central Time anyway, and we'll go ahead and get started on our little webinar here. We have an hour. We're going to target 30 minutes for the presentation, and then after that, feel free to ask questions. You can put it in the chat however you want to do it, and we'll answer the questions at the end. So, to start with, my name is Paul Johnson. I'm one of the engineers for HYTORC and our Productivity Enhancement Group. And today we're going to go over specifically how we are revolutionizing the industry when it comes to hand safety for precision bolting equipment. We have some other features, but today we're going to focus primarily on the hand safety. So we'll go ahead and get right into it. Very briefly about HYTORC, we are worldwide. We're across the globe, and we're in a majority of the countries in the world, and we have coverage that expands to all the continents. So you can't be operating somewhere that HYTORC does not cover and support throughout the entire world. We are available 24/7, and you can always get a hold of somebody. Maybe not me personally, but you will get a hold of someone. So let's jump right in. So what are we talking about today? Well, we're talking about precision bolting. So we're talking about putting accurate torque onto flanges, bolted joints, you name it. And what we're looking at over here on the left is a typical hydraulic power torque wrench. For those of you that are not aware of how these operate, quite simply, we put a large amount of force on a short lever arm. So this tool right here uses hydraulic pressure. That hydraulic pressure comes into the tool, and it's going to push on a ratchet mechanism inside of here that's going to exert a force on this bolt, or a torque on this bolt. The problem is, in order to hold that, we need to react. It's a little bit hard to see here, but there is a reaction arm right here. It's a big piece of metal, basically, that holds against this next nut and allows us to exert that amount of force. Or you can use a long arm, and like these guys are over here, and everybody pushes up on it. The problem with this, of course, is this is quite unsafe. You can see that we are using a long arm here, and we've got a guy holding onto this tool here. We're hoping that it's not going to slip on him, and this can very easily result in an injury. Over here on the left, back looking over here, this is a very, very dangerous pinch point, as we'll get into in a little bit. And these guys' hands are very, very close to that pinch point. And another issue with it is that he doesn't have control over this tool. It's usually being operated by a second operator off to the side. So this guy holds the tool while the operator actually advances it. It can be a very, very dangerous, process. So on this next slide, what we'll see is another big problem with this. There are reaction arms, very large reaction arms, but we also have very large backup wrenches. Okay, so we have to hold this nut on the back side. And in order to hold that, this is going to have to brace against something as well and exert the same amount of force that this front tool is going to exert. Now, I'm assuming this guy is placing this large arm, this large wrench on the back here. He's not actually holding it. There's no way he could physically hold it. And what this arm will do is move one direction or the other, depending on which way we're bolting this tool. Okay, so it can be a little bit deceiving which direction this is going to go, and we don't want to have our fingers there when it goes up and reacts against this next bolt over here. On the right side, we can see that same type of danger where we have one guy operating both tools. So he can only focus on looking at one hand at a time. So if he's looking at this hand, which is quite close to our reaction arm, so our reaction arm is going to be down in this area. Here's his hand. We're very, very close to that. Hopefully he's paying attention to this side as well, because there is a dangerous pinch point on this side as well. Both of these pinch points could cause a lot of problems with this job. So we'll move over to our next slide here. And this gives a very good example, a very good drawing depiction of that pinch point. As you can see here on the left, there's a pinch point between the tool and this guy's fingers. And on the right side, this is actually a more dangerous pinch point hazard, because most times it's being done blindly. A lot of times the guy's reaching around to the back side of the flange and trying to hold this tool in place, and he doesn't really know where his hand is or can't see it. And this actually, because of that, we actually see more injuries related to this back wrench on this side than we do on the front reaction arm. So we now have two dangerous pinch points that that can cause issues while we're doing precision bolting. So I keep talking about massive amounts of forces. Let's go ahead and look at those forces. This is a good example of the risks that are involved that we solve. We actually have a solution now that eliminates these problems. We will get into that solution in detail in a little bit, but you look at some of these ways they're doing it. Up top here, it's very nice when we have a round flange with the bolts located nicely spaced around that flange and very easy to react off of. But what happens when that's not the case, like over here? Well, a lot of times we just kind of rig up some sort of solution using a backup wrench with a piece of channel on it, and we're hoping that this is going to hold and not hurt somebody. And as it results, it does end up hurting a lot of people in industry. And we can see over the right again that same picture with that guy trying to run two tools at one time. We also have some fatigue problems where if we're working inverted upside down, these tools get heavy, you kind of lose focus, and you put your hand where you can't have it. So let's look at what type of forces we're talking about. Now we're going to talk about 7,000 foot-pounds because that's kind of a good number. We see it's a good ballpark number for a lot of bolting applications in industry. It's around that 7,000 foot-pound mark. So when you calculate it out on a tool capable of doing that, the reaction arm down here is going to be 6 inches away. Very quick calculation says that that's going to be 14,000 pounds of load on this single point. That's the equivalent of a large truck, a very large truck, being set on your fingers at one point. That's very important. It would have to be at one point on this. You would actually be better off letting this truck drive over your fingers than actually getting your fingers between this pinch point on the wrench. So again, we're going to look at a couple more safety issues here and talk a little bit about just some quick numbers that we found. We look again, this is not a nice, evenly spaced application here. We're looking at a track on a bulldozer, and we've got to react. And what we're doing is we're reacting here on this tread. And it's not exactly a nice, easy reaction point. The guy has to have his hand in the way. He's got to have it up here to hold the tool on. And if we look, as we move to the next tool, our reaction point is right here, and our fingers are right here. It is a very, very, very dangerous job if you're not paying attention. And on the right here, we have a nice hodgepodge of hammer wrenches and pipe wrenches and all sorts of wrenches being used for backup wrenches. So just not a very safe way of doing it. 27% work-related injuries are due to are getting fingers or hands stuck. But if you look at a heavy industry, we're looking at 43% of all injuries occur to the worker's hands and fingers. So we can see this is not a rare happen. This is not a rare problem. This is a common reoccurrence that we need to solve, and we have done that. So how do we provide value to our partners, to you guys, to our customers around the world? Well, one is job safety enhancements. Two is actually going to be the job quality enhancements, and the third one will be the job schedule reduction. Again, we're focusing primarily on safety for this webinar. However, with the safety comes these other enhancements. So what does this mean for you guys? Well, one, 0 bolting-related injuries. Now, I want to make this clear. We are not minimizing this safety risk. We have a way to fully eliminate that pinch point safety risk. That's a big, big deal. We've engineered out that problem. All right, so what about the job quality? Well, you're going to reduce and eliminate leaks. We have different optimization methods that we now can do to help reduce and eliminate leaks. We'll get into that in a little bit. And job schedule reduction. You're going to easily cut your bolting time in half using this method. We're not searching for reaction points. We're not dealing with reaction arms. It's a very effective solution for reducing job times, overall job times. So how do we go about achieving those zero bolting? I said we eliminate. We don't just minimize. We do eliminate those bolting-related injuries. Well, and this is the big one, is we're eliminating that hazard. The hazard is those reaction arms. We've eliminated those reaction arms. Again, we'll get into how we do that using a washer in just a little bit. Hands-free operation. We now have the ability to, with a couple of small attachments on a couple of tools, utilize hands-free bolting, even inverted, so upside down. We can actually have our tools latch onto the fasteners and operate completely hands-free. You don't even need your hands. Even though we've eliminated the pinch points, we now can get our hands completely out of the way of the work. Manpower reduction. I mentioned earlier, it's very dangerous to have somebody working holding the tool and somebody else running the pump. Well, now we're hands-free, which means you can place the tools, step away, and run the equipment yourself. If you're in control of that operation, you're much less likely to have a communication error. Enhanced worker competency. Once learned, the system is extremely intuitive, very easy to use, and we're going to provide the training and the support and guidance for all of your employees so that they understand what they're doing and they do the job correctly. And we've got enhanced tooling reliability. So injuries related to tooling failures, though it's a smaller percentage, it still is in there. Well, we're not side loading. We're not putting that immense amount. We talked earlier, 14,000 pounds. We're not putting that load through the tool. Instead, we're coaxially reacting. We're canceling those forces out. And now our tools are more reliable. They'll last longer. The failures are not as catastrophic because they're not under those bending moments. So let me go to the second, the job quality. How do we do that? And we do want to touch base very quickly about that. How do we eliminate that leakage, reduce that leakage upon startup? Well, the first is bolt load scatter reduction. And we achieve that through using a through-hardened washer. As we use a through-hardened washer and we can use multiple tools, we can actually improve the consistency of that bolt load around that flange. That means that that gasket's going to be seeing equal crush pressure all the way around the flange. Two is joint integrity enhancement. Okay, so this is where we get into our 4-tool system. We're hands-free. We can use multiple tools on the flange and we can pull it together at the same time. I'll show you how that operates in just a little bit. Enhanced worker competency. This and supervision go hand in hand with what we just talked about earlier. When your workers are more competent and able to do the job better, they're going to reduce and eliminate leaks. We're also going to provide that supervision and that help and that knowledge and expertise from the get-go. We also now offer an advanced software that, on especially critical applications, we can hone in on exactly what we need to get the bolt load to achieve the best seal for that flange. So yet another weapon in our arsenal to attack this leak problem. And we're going to give procedural guidance. So it kind of ties into that advanced software. We can develop the procedures to vastly reduce the chances of leaking. So now we're going to talk about the washer. We kind of led into it. This is it. This is how we solve those pinch point related problems. This is the HYTORC hardened washer. This is an ASTM F436 standard washer. I want to make sure everybody understands this is just a flat washer. There's nothing special about the washer in itself. What's special about it is it allows our tools to eliminate those pinch points and reduce reduce job time and improve the quality of the job. So on the left, down here at the bottom, what you're going to see is the reaction washer. And it's on this side over here, you're going to see these knurls. What these knurls do is provide that point for that washer to hold so that it is not turning as we're trying to torque. As you can see on top, this green washer is that reaction washer. And attached to our tool is this driver. And this driver is actually going to hold that washer while the socket inside turns down the nut. This provides the reaction point, so we no longer need any sort of external reaction point. We are reacting on these lobes on the reaction washer. Now, on the other side of the reaction washer, where the nut is actually turning, is this flat machine surface. And what that does is provide a consistent, smooth surface for that nut to rotate on to better increase translation from torque to load. So we get the proper load on the bolt. Now on the back side, we still have that problem of the backup wrench. We still need to hold that back nut from turning. And we do that by simply taking the same knurling idea from a reaction washer and applying it to both sides of a round washer. And when you put that on the back, underneath the back nut, we no longer need a backup wrench at all. Now, a key note here is that they're just flat washers, which means you're not tied to our tools. Our tools are just standard tools that use this driver. But if in order to get the benefits, you need our tools, but if you're in a pinch and you can't find the driver, a standard tool will take the nut back off, because at that point it just becomes a regular standard through hardened washer. Very simple. All right, so this is good reading material here. If you want a good classic to read, it's the Guidelines for Pressure Boundary Bolted Flange Joint Assembly. Very exciting read here. It is the ASME PCC1 code. And in that code, we're just going to today. I'll leave the plot up to you guys. I won't no reveals or anything for the plot line, but I'm going to show you a little bit in here. One thing is the use of through hardened steel washers. They are recommending using a through hardened, and this is key, is that it is through hardened to better improve the translation of torque input. Okay. Also, with this washer, you're going to protect the contact surface. Okay, so it's going to protect that flange surface from being galled up as you're turning the nut under load. And it's much easier to replace a cheap washer than it is to reface a galled up flange. So it's very key here that the ASME PCC1 guidelines actually recommend using a through hardened washer, which our washer is. And here you can see the system being used. What you'll notice, the big difference between this and the first pictures we showed you, was that there's nobody holding these tools. You'll notice that there is a gap between the tool and the nut, so we don't react on the next nut. We're reacting on that washer. We're holding on to this green washer here. We're actually holding on to that and providing the reaction force. We are also using 4 tools. And what 4 tools allows us to do is parallel close that flange together and evenly crush the gasket. We're not pinching the gasket as we rock the flange together. So this greatly improves the flange integrity, the joint integrity that we talked about earlier. We can vastly reduce leaking problems by using this method with our HYTORC washer and our hands-free bolting system. Down here in the diagram, you can see we simply put our reaction washer under the nut that you're turning. We put our backup washer under the nut you're trying to hold, and everything else is the same. We're not changing anything else. It's the same nuts you're using, the same studs you're using, the same gaskets you're using. We just simply add the washers. We add this dual socket drive right here on the end of our common tools. We're not using special tools, we're just using our common tools. We put this dual socket drive onto the end of our tool, and now we can do this reaction arm and pinch point free. This is the parallel joint closure method we were just talking about in that last picture. What this does is actually show that it's not made up by us. This is the ASME PCC1 guideline for a 4-tool pass. So all you do is simply follow this. You can see here, again, he's operating it down in the bottom, hands-free, with 4 tools across each other, and we're knocking all 3 of those features out of the park. Hands-free safety, no pinch points, no backup wrenches, increased quality of the joint, and decreased job time. And lastly is training. We talked about getting the worker competency up. This is how we do it. We provide all of the training required for free to operate our tools and our equipment. We're going to provide supervision beyond the initial install. If as you guys as customers would like, you can actually hire us to come out full time on all of your outages and help provide that supervision. Now, beyond the first install, of course, there'll be a little bit of a fee, but we can do all of this training. We are the experts in the bolting industry, and we absolutely provide top-notch training to all operators. So when they go out on the job, they know exactly what they're doing. And here on this page, you can see that range of training classes that we offer. Everything from our bolting basics class and our BOSS training, which is the introductory training I was talking about, that first-time training that we teach everyone how to use the tools, is free. If you would like an OSHA 8-hour course, we can do that as well. It is an OSHA class, which does mean that does cost a little bit. And then we have our ASME course. And the ASME course is put on by the ASME board, and it's a very good technical course on pressure vessel bolting. I've been through it myself. One of the best trainings I've ever been through. I would highly, highly recommend it for your technical guys to really understand the criticality of bolting. And it will illustrate that. That little picture on the left just shows, we're all very familiar with the welded joints and the standards and requirements and the NDT testing and the authorized welders, everything that goes into properly welding together a flange. But yet we really don't apply that same criticality to the right next to it, to the bolted joint. And it really should be paid attention to, because it's a leak point just the same as a poorly welded joint is. So that's really all I have. We kept it to under 30 minutes, which is definitely what I was targeting. And just want to ask if anybody has any questions. Feel free to ask in the Q&A. Let's see if looking for questions here. Okay, so Jim sent me a question. It says, do I need a special tool? So I had mentioned that you do not need actually a special tool for this job. You simply need our special driver, and essentially it's just a reaction can with the socket inside. Now this driver will only work with our tools, but you don't need a special tool. Our tool is still a conventional torquing tool. We can still put reaction arms on them. In fact, they come with reaction arms. The only thing that's needed is a attachment to that tool to be able to drive the washer. All right. Jonathan says, how do I go about ordering? Okay, so in order to get a quote for the washers, your best bet's going to be to just contact HYTORC directly. You can go out of the website. A little chat window will pop up. You can request in there that you'd like a quote. They will get you in touch with the best person to talk to, and they'll make sure to get you a quote over there. You can also just go on Google and Google HYTORC, and it'll give you our headquarters phone number. Call them up and say you're interested, and they'll make sure to get you to the right person that'll take care of you. And again, this is worldwide, so you don't need to worry about where you're at. We'll help you. We'll help you get these installed. All right. Bill sent me what materials can these be made out of. Okay. They are stocked standard as a 4140, basically a black oxide steel, and then a galvanized steel washer. So we stock them in large quantities in those two materials. However, they can and have been made out of multiple different materials. One of the projects, in fact, I'm working on right now is with NASA, and we're doing 316L stainless steel special washers. They're actually a thick washer for the piece of equipment that actually moves the space shuttle around. So kind of cool project I'm getting to work on. And yeah, we make them out of any material that's required by the customer, but we stock standard your black oxide and galvanized. I also have a question here. What's the cost? Again, I would definitely get a quote, but I can say they're not expensive. They're a few cents more, 10 to 50 cents, a dollar more than your standard through hardened washer. I didn't mention that earlier. Be careful because actual for a through hardened washer, there are definitely manufacturers out there that do cheaper surface hardened washers, and but for the most part, it's just going to be a direct replacement for your standard washers, or an addition. I see a lot of the customers I work with who currently aren't using through hardened washers, and you look at their flange faces, and they're all galled up because they're turning the nut directly onto the bearing surface, and you just can't get an accurate load when you're turning against that galled up surface like that. So, and that is one thing to note with these washers. Well, you can put them directly on top of a galled up surface. They can handle some pretty nasty conditions, painted flanges, coated flanges. They will work. Let's see. I think that is all I have. Is there any other questions? I have a question here. Do I also achieve a higher quality of my bolted connections due to no bending? Yes, but it's fairly minimal. So I'm going to talk from an engineering standpoint here. There is side loading. What you're talking about is a very good point. As we are bolting that together with a reaction arm, we are inducing a bending moment into that bolt. Whatever forces we're putting into bending that bolt are forces that are lost into the translation through the bolt into the bolt load, which is ultimately what we're trying to achieve. So yes, in a way, you definitely are. It's just not as massive of an amount as I think a lot of people think it would be. And also, back to what I had said about consistency around the flange, that's going to be the important thing with the washer is consistency. So you're going to have equal bolt load all the way around that flange, or less scatter, as I mentioned earlier. I'm not going to say it's dead on equal, but you're going to have less scatter. So yes, technically speaking, you are going to achieve a higher quality. It's just in the bolting world, probably not a very significant problem. So I hope that answers your question. And does anybody else have any other questions? Does not appear so. So we actually kept it pretty short, short and sweet. Hopefully that means everyone stayed awake through it. If there's no other questions, I thank you all for your time. And if you do have any and didn't ask them on here, please feel free to just go onto the HYTORC website, wait until the little chat window pops up, and ask them. You can even say, hey, I've got a question for that engineer that gave the webinar, and they'll direct you right over to me if you want. So please feel free to contact us. Let me know if you have any questions. Thank you all so much for your time, and we'll see you next time.